talking about kites and trapezoids, and a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. Consecutive means in a row, okay? So you have like a segment and an additional consecutive segment that are congruent, and then another segment and a consecutive segment that are congruent. So there's two that are adjacent to each other, okay? And so how are the diagonals of the kite related? Well, first of all, we said the kite has two pairs of congruent adjacent sides. We talked about that. Okay? Now, let's think about this. It says point B is equidistant to the endpoint of AC, as is D. So, this point right here, okay, is equidistant to the endpoints. If this point is equidistant to the endpoints, then what is this line? Perpendicular bisect. Okay? So, if this point is equidistant to the endpoints, then it lies on the perpendicular bisect. Okay? As is this one. Okay? It is equidistant to A and C. So it also lies on the perpendicular bisect. Both. Okay? And so that is what happens with that particular diagonal. Now, if you look at this one, okay, is it bisected? This long one? No, because this is not equidistant, right? A is not equidistant. And so only AC is bisected in this case, whereas D is not. Okay? Alright, so what is the measure of angle AXB? We just said, what is it? AXB is 90 degrees. Okay? And AX is 3.8. What is AC?
3.8.
Well, XB would be 3.8. So it would be, what, 7.6? Okay? If BD is 10, does BX have to be 5? If BD is 10, no, right? It wouldn't be. And we just talked about that. Okay? D is not equidistant to A and C. So DB is not a perpendicular bisect. I mean, said that wrong. A is not equidistant to D, so it is not a perpendicular bisect. Okay. The diagonals of a kite are perpendicular. That's the theorem. Okay? Theorem, whatever, 6-3. Okay? The diagonals of a kite are perpendicular. Okay. So let's answer some questions. Quadrilateral WXYZ is a kite. What is the measure of angles 1, 2, and 3? Okay. Huh? Okay. We know that these are perpendicular, so this is right angle. So what's the 58? Okay, so we added 90 and 32 together and subtracted it from 108. So angle 1 is 58. And angle 2 is what? How do you know that angle 2 is 32? Okay, now be careful. You're right. It is 32. But let's think about this for just a second. We don't know, they have not stated, that this right here is an angle bisect. Okay? This is bisected, but we have not stated that the angle is bisected. Yes. Okay? It is an isosceles triangle, and we can drop the altitude from the vertex. Yes, it does bisect the angle. Okay. What? Okay. Okay, so he's saying that go ahead and put 58 in here. This is an isosceles triangle, right? Okay, so this is going to be 58. The base angles are congruent. You can think of it like that. Okay, this is 32. Now, there's lots of reasons, but I want you to see something. Okay, what relationship do these two triangles have? They're congruent, right? We have these two sides that are equal, right? This is bisected, and then they share this side. So why are these two triangles congruent? By side, side, side. Okay, so that's another reason they're both 32. There's lots of things that you can think about when looking at that. Okay? Alright, good. Okay, now the next thing we're going to talk about is a trapezoid. That's another type of quadrilateral. And by definition, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay? So the arrow again means parallel. So we can see that AB is parallel to DC. Right? The two parallel sides are called bases. The other two sides are called legs. Okay? These are base angles. Okay, right here. These are base angles. That's one pair of base angles, and this is another pair of base angles. Okay? So, these are base angles and those are base angles. They take on a special relationship here in a minute. But I want us to think about what it means for the bases to be parallel to each other. Because this line here is parallel to this. Yes? This acts as transversal, as does this. Right? So if these are parallel and this is a transversal, what relationship does this base angle have with this one? They're not the same. They're equal to 180 because they're what kind of angles? Well, yeah, they're supplementary angles. Same side interior, right? So the measure of angle A plus the measure of angle B equals 180. And then B and C have the same relationship, right? Because they're same side interior. So the measure of angle B plus the measure of angle C equals 180. Okay. Now, we have a special type of trapezoid called the isosceles trapezoid. And in the isosceles trapezoid, the legs are congruent. Okay? So we still have AB parallel to DC, but now our legs, AB, is congruent to BC. So the bases are parallel and the legs are congruent. Now your isosceles trapezoid has some special characteristics. In an isosceles trapezoid, each pair of base angles are congruent. Okay? So here we've got parallel bases, congruent legs. This says that the base angles are congruent. So this angle A and that angle D are congruent to each other. That pair of base angles are congruent. As are the upper base angles in this case, B and C. Alright? So your base angles are congruent. Now, does angle B and A still have the same relationship as the other page? What was that? They equal 180, right? So in an isosceles triangle, the base angles are congruent, and the other pair are supplementary, just like in the regular trapezoid. Okay, so here is a question. Given isosceles trapezoid PQRS, I want to find the measure of angle P, Q, and S. Okay, so the measure of angle P, the measure of angle Q, and the measure of angle S. Alright, so what's the easiest one to find? Q, what's Q going to be? 135. Okay, so Q is 135. Alright, what's S going to be, or RP? What is it, 45? Yes, 45. For both of them? Yes. Because Q and P are supplementary, as are R and S, and then P and S are congruent. So they are both 45. Good. Okay. Given ST is parallel to RU, what is the measure of angle TUR? Now, before you answer this, what is this shape? This quadrilateral, STUR. It is a trapezoid, it's just turned upside down, right? You still have the parallel sides. It is not just a trapezoid, but an isosceles trapezoid. Okay. Alright, so I want to find TUR. So what am I going to have to find first? SRU, and I heard somebody say they're a linear pair, so I'm going to have to do 180 minus 47, 133. So this angle right here is 133, which makes TUR what? Alright. The diagonals of an isosceles trapezoid are congruent. Okay? So the legs are congruent in an isosceles trapezoid, and also the diagonals. Right? And so value of a. So the given expression represents this diagonal, that's 2a minus 1, and this one is a plus 13. What relationship do those two diagonals have? They're congruent, right? So I can set 2a minus 1 equal to a plus 13. Okay? And so solve for a, subtract a, add 1. Okay, and what's asked we find? Just a. So a is 14. Okay, we have another theorem called the trapezoid mid-segment theorem. Okay, it says in a trapezoid, so this is any trapezoid. In a trapezoid, the mid-segment is parallel to the bases, and the length of the mid-segment is half the sum of the length of the bases. Now, first of all, what is a mid-segment? Okay, a mid-segment is a segment that connects the midpoints of the legs of a trapezoid. So let's write that definition down. The mid-segment is a segment that connects the midpoints of the legs of a trapezoid. Okay. So in this case, XY is a mid-segment. Alright, so you can see it connects the midpoints of the two legs. The legs aren't equal because one of them, this on the left side, EX and AX both have a single dash, and CY and CY. So this is any trapezoid. Okay, so XY is the mid-segment. And then it says that it is parallel to the two bases. So all three lines are parallel to each other. Okay? And its length is half the length of the sum of the bases. Okay, half the length of the sum of the bases. So let's say that this one is 20 and this other base is 50. What would I do to find the mid-segment? Add them together and divide by 2. So that would be 20 plus 50 equals 70. Divided by 2, 35. Okay. Alright. Given trapezoid JKLM, what is KL? Okay, so that is this up here. That's what I'm looking for. Now I can see that this mid-segment is 25, right? And I can see that JM is 4/5 times XY. What's 4/5 of XY? How do we do that? 4/5 of 25. Well, that's too hard. I can do that in my head. You can do that, absolutely. Okay? What could you do though? How would you do it mentally? 25 is divisible by 5. That goes how many times? 5 times 4 is 20. Now somebody in my last hour, they did it a little differently. They went ahead and multiplied 4 times 25, which is 100, and divided by 5, which is 20. Or you can be mid and multiply by 0.8. It doesn't matter. It works either way, right? Any of those. Okay. So that means that this down here is what? 20. Okay, so now what am I going to do to find KL? So 25 equals half. Okay, 20 plus x. I will let this appear as x. Okay, so now I just have to solve for x. Okay, what should I do to solve for x? You could distribute the half, yes, absolutely you could distribute the half. Could I multiply both sides by 2 and eliminate the distributive property? That's probably what I would do, yes. You can, and you know what, that's what I'm doing right now. Okay, I'm going to double the 25, okay, which is 50, okay, and then I'm going to subtract the 20, okay. I just want to show you mathematically how to do it, because what happens sometimes is people do all this stuff mentally and they don't really realize what they're doing. So I just want to make sure you understand. Okay? And some people need the formula. So, yeah, but you're right. That is essentially what you're doing. She says, can you just double this and then subtract that? Absolutely. And that's what I did, right? I set the formula up, I doubled it, and then I subtracted it. Right? So, either way. Very good. Alright, we got one more. Paxton makes trapezoidal handbags for her friends. She stitches decorative trim along the top, the middle, and the bottom on both sides of the handbag. How much trim does she need for 3 handbags? Okay? Alright, so she's going to stitch stuff here, here, and here. Yes.
We'll give Aaron land down to the main office for a moment.
Yes. Okay, so we're going to stitch stuff here, here, and here. Now we know this one's 6. We know this one's 9, right? We don't know what this one is. Okay? So, what is this right here? This line through the middle. Okay, but what's it called? A midsecond, right? Okay, because it's connecting the midpoint here and here, right? Because this is 2 and 2, and 2 and 2, right? So, it is half the sum. So we take 15 and divide by 2, which is 7.5, right? So this right here then is 7.5, right? Okay, so how am I going to figure out how much stitching I need? Okay, we are going to have to take our final answer times 3, but also she's doing both sides. Okay, so first of all I need to figure out how much she needs for one side, right? Okay, so if I took one side, that would be what, 22.5? Okay, so one side is 22.5, but she's got to do both sides, right? Which is going to be 45, correct? And how many bags is she going to do? You got to multiply by 3 because she's going to do 3 bags. So what's that? 135. So 135 inches. There. 135 inches. Okay. So real quickly, we talked about kites and trapezoids. First of all, we talked about a kite. You have 2 consecutive sides that are congruent. What do the diagonals do? They're perpendicular, right? And one of the diagonals is bisected. Okay, the one that connects the 2 different sides, that one's bisected, the other one's not. Now let me ask you this, I didn't talk about this a while ago. You think you might have to do Pythagorean theorem at some point? No. Good. Okay, there's a right triangle there, alright? A couple right triangles. Alright, so the one diagonal is bisected. They're perpendicular to each other. Okay, then we talked about a trapezoid, right? We said a trapezoid has 2 bases that are parallel, and it has 2 legs, right? The legs act as transversals, so we get some supplementary angles with A and D, and B and C, okay? An isosceles trapezoid, what's special about an isosceles trapezoid? So the legs are congruent, what else is congruent? The diagonals are congruent, and another thing. The base angles, okay? The base angles. So the diagonals are congruent, the legs are congruent, and both different pairs of base angles are congruent, okay? And I think that's it, isn't it? Oh, mid-segment theorem. That works with any kind of trapezoid. The mid-segment connects the midpoints of the legs. What's its relationship to bases?
It's half of
It's half the sum. What else? They're parallel. So don't forget you're going to have some special angle pairs, okay? Like, these are going to be, what? Supplementary. What about these? This one and this one, what are they? They're corresponding, and corresponding angles are congruent, okay? So don't forget about all that.